I want to make mention of this 1 over x function because this 1 over x function is a fairly significant function. It shows up in a number of different areas of calculus. And in particular, this 1 over x area from 1 to infinity. This 1 over x function is actually a boundary function for series and differentials. And it's a boundary function because we can see that the area from 1 to infinity is infinite. And in fact, this is the boundary of what are infinite areas and what are finite areas. So this 1 over x function, if I just sketch this, we get this 1 over x function that looks like this. And from 1 all the way to infinity, as we integrate this, this is infinite area. And it's a boundary function because when we look at powers, any reciprocal functions that have powers that are any less than this, so for example, x to the square root, or any power less than 1, what ends up happening is the denominator does not get as big as quickly, and what ends up happening is it does not go to 0 quite as fast. And that means that if that green area is infinite, that means that this area must be bigger and also infinite. And the converse is then true. Because 1 over x is a boundary function, if we let that denominator get bigger quicker, what will happen is this graph will go towards the 0 faster. So it's going to go to 0 faster than the function over here. So this means that that green infinity over to the left, this area in here, which I'm going to draw in a different color, this area in here must be smaller than this infinity over here. And it happens that, although smaller than infinity can still be infinity, it happens that this area is finite. Okay? If we can go any faster to 0, it pinches off the area quicker, and it means that the area is finite, which makes 1 over x a boundary function. Anything bigger than the 1 over x area is infinite. Anything smaller is finite. And this is why it's a boundary function. In fact, it's an important boundary function that shows up in lots of different areas in calculus.